Same idea for this one as this one, except it's a trig function on an interval. So let's find our critical numbers. Let's first derive. So when we set our derivative, or not, we solve or find our derivative. Derivative of x is 1. Derivative of sine x is cosine x. So this is plus 2 cosine x. That was a nice easy derivative. You're going to set that derivative equal to 0 to find critical numbers. And when you do that, you're going to minus the 1 over. And when you do that, you're going to get 2 cosine x equals negative 1. Then you're going to divide by 2. And you get cosine x equals negative 1/2. The reason I did that is you can actually find out on a unit circle when cosine is negative 1/2. Okay. If you think of your unit circle, where is cosine negative 1/2? Well, isn't that right there and right there? Isn't cosine negative 1/2 on those two values? And those two values of the unit circle would be when x equals, the first one is 2 pi over 3. And the other one down here is 4 pi over 3. Those are your two critical numbers. Okay. For the interval. So we're going to make a table with these as my breakpoints. So we're going to have 2 breaks. My first interval goes from 0 to 2 pi over 3. Is that correct? Yeah. And then from 2 pi over 3 to what? To 4 pi over 3. And then from 4 pi over 3, kind of squeezing these in, to 2 pi. Kind of had to squeeze it in. Made it too small. So let's plug in a value for f prime. What's an easy one here? Just pi over 2. Looks like a good one. So we're going to plug pi over 2 in. And for this one, you want to just plug in pi? But would pi work?
Yes.
It's an easier one maybe to... does pi not work? Pi should work.
It works.
Yeah, it works.
And this one, maybe put in a 3 pi over 2. When you plug those in, when you do pi over 2, to your derivative here, what's 1 minus 2, 1 plus, and what's cosine pi over 2? Cosine pi over 2, pi over 2 cosine, isn't that cosine 0? So isn't that 1, which is positive? So isn't this increasing? And the next one, when you do pi, 1 plus 2 times, what's pi? Isn't pi negative 1?
Yes.
So won't that be a negative 1, which isn't this negative? So it's decreasing. And then the last one, interval, 1 plus 2 times, with this one it's 0 again. So isn't that positive? So it's increasing. So we did our critical numbers, we found increasing, decreasing, now we want relative extrema. Do these values actually exist? Do we actually have coordinates here? Yes, we do. This one's going to be 2 pi over 3 comma something. This is 4 pi over 3. If you plug these into this equation, something does exist. Now, what is the part of what is it when you plug it in? What goes in right here? Well, if you plug 2 pi over 3 isn't this going to be I need to make this parenthesis bigger if you haven't figured that out. If you plug 2 pi over 3 here, isn't just going to be 2 pi over 3 plus, what's 2 times 2 pi over 3? What's 2 times cosine 2 pi over 3? Sorry, sine 2 pi over 3. Well, sine 2 pi over 3. What's sine? You're going to run out of space here. You're going to end up with just the square root of 3. That's the back of it. And this one is going to be, when you plug it in, 4 pi over 3. And this one, when you plug in 4 pi over 3, don't you get negative? Will this one be negative? So this becomes negative square root 3. Sorry. You can't really see it very good. I should have chosen a different color. Could you find a decimal for those? Yeah. Now, you have 2 coordinates here. When you plugged it into here. Okay, by the way, how do you find these orange numbers? You plugged it into the original function, not the derivative. And will this be a relative max or min? Well, if it goes from increasing to decreasing, isn't increasing to decreasing look like this? Which isn't this a relative? Isn't this a relative max? And since this one is decreasing to increasing, it's a relative min. So we have a relative max and min. We have our interval table. We have our critical numbers. Okay. And again, be careful with those values for your coordinates. Plug it into the original function. And when you plug in these values, when you find values to plug in the intervals, plug the values into your derivative, not your original function, and choose the best, easiest value you can on each interval.